So where does this go next? Well, we alluded a couple of times throughout this lesson that the rules we learned were great for the types of functions that can be expressed with constants, coefficients, sums, differences, but we are going to have a couple of special rules coming forward to handle things like products and quotients in particular. So let's take a look at a function. Let's consider the function f of x equal to 3x squared plus 7x minus 4 all over 4x plus 8. And let's say that I want to find f prime of x. Well, now remember, when we did the splitting up the rational function, I can do that if there's only a single term in the denominator. Now I've got a binomial in the denominator, so I can't simply split this up. Or if I tried to, everything would have to still be over 4x plus 8. So like 3x squared over 4x plus 8 plus 7x over 4x plus 8. And it doesn't really get me in a position where I can then express it in terms of a polynomial, everything in terms of x's. So right now, we're stuck on not being able to take this derivative. So we can't break it up. We cannot break f of x up. And the main reason is because the denominator is a binomial. So in other words, that binomial is going to have to be the denominator. I guess I could break it up, but again, it's not going to get me any closer to being able to write this in terms of a polynomial. So we're going to need some derivative rules here. And they are going to be different from limits. When we look at products and quotients, we're not going to be able just to multiply the derivatives or divide the derivatives in the case of quotients. So we need derivative rules for the following. We need to learn how to take the derivative of products. That comes in topic 2.8, so in the very near future. And then right after that, we'll learn the rule for taking the derivative of quotients, and that's going to occur in topic 2.9. I will tell you when we do the derivative. So for example, we'll be able to do the derivative of this function after 2.9. It is going to involve us being able to take the derivative of the numerator. So we're going to have to be able to use those rules that we learned today. But it is not as simple as just saying the derivative of the numerator divided by the derivative of the denominator. The rule is a little bit more complex than that, and we'll cover that here in a future topic.